Hi everyone, welcome back to the channel. I'm the GCSE Science teacher, and in today's video we're going to be doing part 2 of the titrations topic for GCSE Chemistry. So if you do enjoy the video, please do give it a big thumbs up, share it with someone else, and also please do subscribe if you haven't already so you don't miss any uploads from me as we approach the new term ready for our GCSE exams to begin. So if you haven't watched the first part of this, I really recommend you do so, but also have a look at the moles video I did, because that will kind of give a bit of a backstory into some of the key information you need to know for this topic. But essentially, during the titrations practical, you'll gather some data, and this can be used to do some calculations, and you do need to know how to do this for the exam if you're studying the higher tiered course or even triple science. So what do you actually need to do? Well, you need to calculate the concentration or the volume of a solution depending on what you've been given, and you also need to be able to calculate the MR, or the relative formula mass, of those different solutions using their formula and their atoms and the periodic table. But you also do need to be able to convert the units of volume from centimeters cubed to decimeters cubed, all of which I'm going to show you how to do today. You also do need to know the equation, which is concentration equals moles divided by volume, and you can see the units for everything under there as well. One big piece of advice for you: anything you type in your calculator, you must write it. If you're a long time subscriber of mine, you'll know if you type it, you must write it. That is kind of my saying here on YouTube, and also in my real life job where I teach students GCSE sciences. So definitely recommend, if you are going to type anything in your calculator, please do show you're working out, because if you get an answer that's not quite right at the end, if you show you're working out, you get something called error carried forward in the GCSE exam. And for this type of calculation, because there's so many steps to it, you definitely want to make sure you have written down and labelled what you are calculating. So it's really easy for the examiner to understand you're working out and then give you the marks accordingly. So the first type of calculation is to calculate the concentration of a substance. So the question is, in a titration, 35 centimeters cubed of 0.100 moles per decimeters cubed of sodium hydroxide solution is exactly neutralized by 25 centimeters cubed of a dilute solution of hydrochloric acid. Calculate the concentration of the hydrochloric acid. So the first thing you want to do is label your equation. You can see NaOH is your sodium hydroxide solution, and you can also see that the HCl is your hydrochloric acid. So label those, you know what they are. You also want to make sure that you know that hydrochloric acid is the concentration we're working out, but we do have a volume for it. We have the volume and we have the concentration of the sodium hydroxide. Remember, in a titration, you're trying to add an acid and an alkali together to get a neutral point. So let's see what we need to do first. Well, the first step is to convert our units for volume, because we have a volume in centimeters cubed, and as you can see, concentration is measured in moles per decimeter cubed. So that's the first step. So what we need to do is we need to convert centimeters cubed to decimeters cubed by dividing by 1,000. So if we do 35 divided by 1,000, we will get an answer of 0.0350 decimeters cubed. And that's the first little bit. So that's the conversion of that volume. Then we want to work out the moles that we have in this case. So the moles is equal to the concentration times the volume. So we're going to do 0.100 concentration times 0.0350 from the volume we've just worked out. And that will give us an answer of 0.0035 moles. Remember, this is for the sodium hydroxide, because that's the only thing at this point we can actually work out, because we don't have any other information for the hydrochloric acid. So we have to work with what we have first. A lot of students will ask, Miss, I don't know where to start with these calculations. Go with what you know first, and then you can work out the rest. So after you've got the number of moles, you want to look at the equation and figure out the ratio between the two reactants. So if you look at sodium hydroxide and you look at hydrochloric acid, there is no number in front of them, which tells you there is just a one coefficient in front of them. So it's just one lot of each. So the ratio is a 1-to-1 ratio. So that means if we have 0.0035 moles of sodium hydroxide, it will react with the same amount of moles of hydrochloric acid. So then we use the same number of moles that we've just calculated, and we put this into our equation, concentration is equal to the number of moles divided by the volume. And again, in this situation, you want to convert your volume for hydrochloric acid, the 25 centimeters cubed, into decimeters cubed. So you want to divide that by 1,000 again to get 0.025, and then you should be able to get your answer, which you can see on the screen there. So those are the steps that you'll need to take to get that calculation for concentration. The only other way they can ask you in the exam to express your answer is to actually use something called grams per decimeters cubed, which is another way of stating the concentration, but in a different unit form. So to do this, you need to use the relative formula mass. And essentially what you're doing is the bit at the top of the screen is everything we've just calculated ourselves with the first question. But what we're going to do is we're going to use the relative formula mass of hydrochloric acid. So hydrogen has a relative atomic mass of 1, and chlorine has a relative atomic mass of 35.5. You add them together, we get a relative formula mass because it's a formula. So it has a relative formula mass, or the MR, of 36.5. We're actually going to times this by the number of moles we've just calculated, and that should give us our answer in grams per decimeters cubed. So this is the final type of question they could ask you in the titrations practical, and it's how to calculate the volume of a solution. So you're given an equation: 2 lots of sodium hydroxide reacts with 1 lot of sulfuric acid to make a salt and water. The salt is sodium sulfate, and if you would like to know how to name salts, I would recommend the video I recently did on it, so I'll link that for you. The question is 26 centimeters cubed of 0.32 moles per decimeter cubed of sodium hydroxide solution is exactly neutralized by 0.15 moles per decimeters cubed of sulfuric acid. Calculate the volume of the sulfuric acid needed. Well, again, in this sort of question, you want to label the things underneath the equation and write down the numbers of what you know. So sodium hydroxide, we know the volume, we know the concentration. The sulfuric acid, we know the volume, we know the concentration, but we do not know the volume. And therefore you need to write that down. One thing to say, the volume again for sodium hydroxide has been given in centimeters cubed, so we start from there. We want to convert it into decimeters cubed by dividing by 1,000. We get an answer of 0.0260, and then we can use this to calculate the number of moles in sodium hydroxide. We should get an answer of 0.00832 moles, and then we can use the ratio between sodium hydroxide, which is 2, to the sulfuric acid, which is 1. So a 2-to-1 ratio tells us we need to divide the number of moles by 2. So we get an answer of 0.0416 moles for sulfuric acid. We then are able to pop this into our equation once we've rearranged it so volume is the subject. So we are doing the number of moles of sulfuric acid divided by the concentration that we're given, which is 0.15, and we are given an answer once we calculate it as 0.02773 decimeters cubed, and that is our unit, because remember the concentration is showing us decimeters cubed, so we don't need to do anything else at this point. Thank you so much for your time today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, please give it a big thumbs up, share this with someone else, and also do subscribe if you haven't already. Thank you so much. Have a great day and I'll catch you in the next one. Bye.